Today we're going to look at solving equations and inequalities that have roots in them. A root is often referred to as a radical. Now, there's times when you can go through and correctly solve an equation or an inequality, but the answer you get doesn't work in the original problem. That's referred to as an extraneous solution, which is a solution that you get from correctly solving it, but it doesn't work in the original problem. For the most part, when we're trying to solve radical equations, we want to get the root by itself first. Then we need to undo the root because there are variables inside of the root. And then we're going to just solve it like normal. So let's consider this next problem. We want to first of all get the root by itself, so we'll go ahead and add 1 to both sides. And we end up getting this. Now we need to undo our root. We have a square root. To undo a square root, you then want to square both sides. So if we square both sides, we square the left side, it gets rid of the root. Square the right side, we get 36. So then we just have to simply add 2, and we get an answer of 38. Now typically when you're raising both sides to an even power like we did, there's a good chance you'll have an extraneous solution. What I mean by good chance is about half the time your answer you get won't work. So we need to check our answer of 38 into the original problem. So we'll go ahead and go the square root of 38 minus 2 in the root minus a 1, and we'll see if it ends up equaling our 5. Well, 38 minus 2 is 36. Square root of 36 is 6, and 6 minus 1 is 5. So we get 5 on the left side, 5 on the right side. So we get 5 on both sides. So yes, our answer does work. So our answer is 38. Well, here we typically want to get our root by itself. Well, we have more than one root. When you have more than one root, you can't always get it on one side by itself. So we'll just, for the most part, try to get the more complicated looking root on one side by itself, which it is. So we'll go ahead and we'll try to solve this by squaring both sides. Well, when you square the left side, that square undoes your square root. Squaring the right side, remember squaring means multiplying by itself. So we're going to have this, and now we're going to have to FOIL that out. Left side doesn't change. Multiply our first terms, multiply our outer terms, our inner terms, multiply our last terms, and negative times a negative is positive, and root x times root x is x. Well, now we want to go ahead and continue to solve this. We simplify it down by putting our two roots on the right-hand side together because they're like terms. Now, you'll notice our original problem started out with 2 roots. We're now down to 1 root, so we're making progress. So now we just want to go ahead and repeat kind of what we were doing before of getting the root by itself. To get the root by itself, you could go ahead and subtract an x from both sides, and then we'd have to get rid of the 4 by subtracting a 4 from both sides. Well, x minus x is 0, negative 12 minus 4 is negative 16. The 4 is over here dropped, the x is over here dropped, so it leaves us with our radical term. Then we can go ahead and get rid of the negative 4 by dividing by negative 4. And then we can get this, get our root by itself, so then we square both sides and we get 16 for our answer. Now we need to check it into our original problem. So put 16 here and put 16 here. So 16 minus 12. And then over here we're going to have 2 minus the square root of 16. So we get 2 on the left. Right side we get negative 2. Well, the left side doesn't equal the right side. It's a false statement, so our answer doesn't work. So we're going to say we have no solution. Now, you might be thinking we don't have a root here. But remember, a 1/3 power or a fractional exponent really represents a root. So we'll want to get that by itself by adding 3 to both sides. Now, you could leave it as a 1/3 power. I'm going to write it as a cube root because that will help some people. Then you want to undo your cube root by cubing both sides. Left side, the cube and the cube root cancel. Right side, we get 27, and we just solve it like normal. Now we want to check that, take our 13, plug it in, see if it works. And in this case, it does work. We get the same number on the left side as we do on the right side. So that's what you need to do to be able to go about solving radical equations where your variable's inside of the root. So try this one on your own and then watch the video. We'll square both sides. Square undoes the square root on the left side. Remember the right side, squaring means multiplying by itself. FOIL out the right-hand side. Then you want to go ahead and get the radical by itself. Divide by 2, square both sides, you get 4. Now you want to plug 4 into your original for both of your x's to see if it works. So we get 9. Square root of 9 we know is 3. The right side we get negative 3. Doesn't work, so we get no solution. Solving radical inequalities is pretty much the same with one small exception. So we'll solve it by the way we were doing before, getting the root by itself. So we'll subtract a 4 from both sides, square both sides, and we end up getting x is less than or equal to 5. But we also have to remember that what's inside of our root right here can't be negative because we can't take the square root of a negative. So what's inside of our root, the 3x minus 6, can't be negative, which means it has to be greater than or equal to 0. So I'll take what's inside of the root. Can't be negative, so it means it has to be greater than or equal to 0. Then we'll solve that by adding 6, dividing by 2. So for our problem, we need numbers that are less than or equal to 5, and x is greater than or equal to 2. It's an and statement. So we want numbers that are both greater than or equal to 2 and less than or equal to 2. When you think of that on a number line, it's really in between these two. There are times where this second part here will not affect your answer. There are other times where this will affect your answer. So just be aware of that, and we'll put a couple of graphs on the board to help you understand that in class.